So this may not seem like it, but this problem is very similar to our body temperature cooling after death problem, like I did the end of class on Friday, where I just walked you through quickly a function that I fit to the data, and I was using that to calculate secant lines. So here they give you a function, it's your favorite cosine pi x, and they give you a point, 0.50. And that's when you plug 0.5 into x in radians and take the cosine of that angle, the y value is 0. So that's your p. And they give you a bunch of x values to find the secant line slope through. So this is very similar to 2.1 number 3. Your function's different. It's 1 divided by 1 minus x. I forgot, hopefully it's not at x equals 1 that you need to find a secant line. I don't think so, that would be very hard. So what did I do? Well, I did the first one by hand. So you should always know how to do something by hand, but I did also plot all those x values. I just went in here in Excel and I had it give me the y values for all these x values because that was not given in the problem. And just so you can see it, this is what it looks like. I just this is my worksheet for this section here. All I did was I put all the x values first in this k column, and to get the y values, the formula is cosine pi with open brackets like this. That's just pi, that's the way Excel does pi, times k2. And then once you do that, first one, all you have to do to get all the rest of the values is go double click on the lower right bottom edge, and you will get all the y values. Right at 0.5, I put 0.5 in there, it's going to give you a mistake, and that's because right in the slope, and we'll get back to that in a second. That's just because you're right on top of that point at that moment. All right, let's go back to the this sheet. This is the thing graph, just screenshot it in here. Your P is somewhere by 0.50, somewhere in that cluster of 3 points that are down here. And they want you to take the Q from different points and then connect the line and find the slope. And so what I did is I just did the same thing as the previous problem. I just reduced it to the previous problem, really. I got my sample of points, made it on Excel so that I could see it, and then wrote them down, labeled my x1, y1, x2, y2, and I'm going to calculate the slope just like I did before. So the slope between this Q and this P is -2. I hope. I'm going to find out in a second if I made a mistake. Then they want you to do another point. So this is 0.4, 0.3, the second row here. I labeled that point out here, labeled my x1, y1. My x2, y2 stays the same, and I go through the computation one more time. And I get -3.09017, something like that. All right, so you can do it like this for each one of the points that you're given. I chose not to. I went to Excel. I told you I'm kind of lazy. Oh, it is -2, so it worked out. So what I did is I went up here. Let me show you how I did it from scratch. So I went up here and I said, okay, here's my thing I want fixed. That is in row 6. And so I'm going to fix my Y2. This is my Y2. It's in the 6th row. And this is my x2, and I'm subtracting out this is my y2, y1, and this is my x1. And then I just double click right here, and it gives me all the slopes all at once, except for that highlighted row. That highlighted row, I'm right on top of it. The P and the Q are the same there, so it gives me something bogus. But you can see the closer I get, it looks like it's converging to pi. I'm using the word converging. We're going to use that in class. So my guess is that the slope is pi.